So far we've looked at how to find the square root of things like perfect squares, how to find the square root of non-perfect squares, and variables. And really when we say how to find the square root, we're just kind of talking about how to simplify these so that they look smaller. So now that we can do all of these three things, we can put it all together. So here's an example of a coefficient, a number that is not a perfect square under the radical, and variables under the radical. So we want to use our really handy our really handy rule for radicals, which tells us that if things are underneath the radical and being multiplied together, they can be split up underneath two different radicals. So we can take this expression and split it up to be 4 as a coefficient, root 80, root 6, and root y squared. Now, at this point, we want to ask ourselves, can we simplify any of these square roots? We're going to leave this coefficient by itself for now. We'll multiply it back in later, but we want to ask ourselves, can we simplify this? So, let's look. Can we take 4 times root 80 times x times y squared, and can we simplify any of these? Well, the answer is no for x, because nothing times itself equals x, but we can break up 80 and we can simplify y squared. So when we factor 80, we see the largest perfect square is 16. So we know that we can rewrite root 80 as root 5 times root 16. And then we'll drop down that x. And we know that the only way that we could have gotten y squared was just to see it as y times y. So we ask ourselves again, can we simplify here? So we'll keep our 4. We can take the square root of 16, so that is 4. So taking care of that, taking care of that. We do see a pair of variables here, so we can bring them outside of the radical. And then we can't do anything with root 5 and root x, so we'll just leave those two terms. So now we just need to combine any of our like terms and just kind of make this thing look more simple. So 4 times 4, and we can multiply anything outside of the radical as well as whatever is inside of the radical separately. So 4 times 4 is 16. And then since we know we can take something underneath a radical and then break it apart, we know that we can put it back together. So root 5 times root x can really just look like root 5x. So that was one example. Let's work out another. Root 20. Now, I encourage you to pause the video now and try this one on your own, and then come back and see how it was worked out and see if it matches what you were doing. So when we simplify this, we know that we can break apart these two radicals. It's not really a necessary step, but it is good to see the difference between these two radicals and what you can do with them. So once we factor 20, we see that our largest perfect square is 4, which means we can rewrite root 20 as root 4 times root 5. And then let's go ahead and simplify this y to the 4th power. So we know that y to the 4th power is the same thing as y times y times y times y, and we see two pairs. So we'll get y squared. We can simplify root 4 a little bit. And then this y squared is a coefficient. It's no longer under the radical, so we'll put it in front. Then we're left with root 5. So this process is really short and kind of sweet. It's really to the point. So it's something that we just have to practice a lot of. The understanding can come along with a lot of practice. Here's another example. Root 100 times x to the 5th. Well, here's a perfect square. So this is really nice and convenient that we know that once we separate these two things, we can really just go ahead and take the square root of 100, and that's 10. And let's break this thing down. It's x times x, 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 x. Okay, so we see two pairs of x's there. So that would be x squared, and then you leave one of those x's underneath the radical. So it looks a little sloppy down here, so I'm going to rewrite it right beside its original expression. Here's another example for you. Five times x root x squared. So can't really do anything with the 5 since it's a coefficient. Let's take care of whatever is underneath the radical. We see one pair of x's that we can take out, and we know that that's just 5x. So I'll be posting some practice problems. Hopefully this video should help you answer a lot of them. When I post the practice problems, try them on your own on the paper, and if you need any help, just take a picture of it with some sort of device, your laptop, your phone, and then send it to me through an email and ask me any questions that you need. And I can be sure to answer your questions digitally if that's the case, or if not, bring them into class and we can talk about them. I actually want to give one more example before we get off. Here we were showing how we can take numbers that are not perfect squares and simplify them, and then variables, and do it all at the same time. Here was an example of a perfect square and some variables and how we can break it all down. And so I want to make sure that we just show, like, sometimes you can just have coefficients and non-perfect squares underneath the radical, and the same thing is still required, just to break down what's under the radical. 2 and 6 and 3 and 4. 4 is our largest perfect square, so we know we can rewrite this as this, and then we ask ourselves, can we take the square root of any of these, or can we simplify this anymore? And, well, we can take the square root of 4. Can't take the square root of 3. And we're done. So yeah, I'm going to post a practice worksheet. Let me know if you have any questions. I'll be posting another video on adding, subtracting, multiplying, and distributing, and a final video on how to find the area and perimeter. So thanks for watching.